Yes. Dear students, let's move on to the next question, that is, what is the product formed here, that is the aldehyde. So here they are asking what is the name of the reaction. My dear students, just take the keen observation. We have taken the presence of the aldehyde group. Yes, the aldehyde is the product which is formed here, and here the reagents we are using, that is RCN and SnCl2, that is stannous chloride. This stannous chloride, it is reacted with the cyanide. It is going to form the alkene as the intermediate. So alkene, it is the intermediate formed by the addition of the water molecule. It is going to form the aldehyde. My dear all, they are asking the name of the reaction. Here just you have to think, this is the Stephan reaction. How it is comes, just remember the reagent used here as the stannous chloride. Without any doubt, the formation of aldehyde is considered as the Stephan's reaction. Yes, so here also they are asked for the name of the reaction. This reaction is followed by taking the again aldehyde. So this aldehyde is treated with the sodium hydroxide, forming the alcoholic group. Here this formation of the alcoholic group, it is clear that the alpha hydrogen, observe about the alpha hydrogen which is present in the aldehydic group, and here the alpha hydrogen reaction undergoes directly the Kenizorose reaction. The name of the reaction takes place here is the Kenizoro reaction. Right. Next, we shall move on to the next question. Yes. Yes. Here RCOR, it is undergo hydration in the presence of zinc amalgam and the concentrated HCl. Here it is very clear that if you are considering the aldehyde or the ketonic group, aldehyde or the ketonic group undergo hydration, that is addition of hydrogen in the presence of zinc amalgam, the formation of the hydrocarbon takes place. The formation of the hydrocarbon takes place. It is clear that this is the Clemmensen reduction. Dear students, it is of the two forms. Either they will ask for the right to name the reaction, or they will ask to write the reaction by yourself for the reaction they have given. Okay, for these two parts you have to think that either what are the reagents you are used, what are the catalysts you are used, and what is the name of the reaction formed. Yes. Next, we shall move on to the next question, that is how benzene is converted to benzaldehyde by Gattermann-Koch reaction, and write the equation. So they are asking conversion of benzene into benzaldehyde. It's very clear. You just write the equation. They are asking to write the equation. So either you can think about the Gattermann-Koch reaction or the formation of benzaldehyde using the benzene. Yes. So by using the benzene you are going to form the benzaldehyde. So here what are the reagents you are going to use here? That is the CO, that is the carbon monoxide and the HCl. These reactions undergo the following of Gattermann-Koch reaction, or they are directly asked conversion of benzene to the benzaldehyde. Now we shall move on to the next question, very important question in the amines. So they will ask for the 2 marks. How do you convert the phthalic acid into phthalimide? So conversion of the phthalic acid into phthalimide by giving the equation. So my dear students, you have to be very clear about the structure of the phthalic acid. So it's very clear, acid, it is of taking the conversion of into the phthalimide. First we are taking the acid, that is carboxylic acid, by the addition of NH3 group, by the addition of NH3 group. So here this phthalic acid is taken by the addition of the ammonia group, that is COO minus NH4 plus. So I am just adding the ammonia to the same content of the phthalic acid. Now what we have to do, you have to remove the water molecule and you have to heat the above product. Then you are going to form the product, that is by the removal of the water molecules. So water molecules, that is 2H and 1O. So here there is only 2O, I am taking only 1O, CO NH2 and CO NH2. Then considering the same reaction, so by the addition of again the ammonia, by the removal of the NH3 group, here we are removing the NH3 group and it is again strongly heated. So now the formation of the phthalimide. So the formation of phthalimide you have to consider here. So CONH2, in that you have to remove the NH3 groups. So while removing the NH3 groups, the formation of the product, that is phthalimide, by the NH group. So by this reaction you are going to prepare the phthalimide. So it's very clear, the formation of the phthalimide by the phthalic acid by addition of NH3 and removal of NH3. So the middle content is removal of water. By this you can convert the phthalic acid into the phthalimide. Next we shall move on to the next question, that is explain esterification reaction with an example. So esterification reaction, so what are esters? First, esters are nothing but the functional group which are carrying or COO or dash, that is the formation of ester. So in the esterification reaction, so we are considering the carboxylic acid. By using the carboxylic acid you can prepare the ester. So this carboxylic acid is treated with the alcohol in the presence of the hydrogen. You are going to form the esters. So they they are asking for the example. You can take the general example. So C2H5COOH in the presence of C2H5OH, the same reaction. So now substitute for the R and R dash, that is C2H5COO C2H5. My dear all, just substitute the R place and the R dash place with the C2H5, that is ethyl group. By that you are going to prepare or the formation of esters, that is called as esterification reaction. It is considered for the 2 marks. Next, the formation here, name the product formed when sodium acetate is heated with soda lime. So when sodium acetate is heated with soda lime, what is the product formed here? So let us consider the sodium acetate. Yes, so acetate, acetic acid, or we can take CH3COONA. So one H group na remove ಮಾಡಿ sodium na substitute ಮಾಡ್ತಾ ಇದೀವಿ. So sodium acetate is heated with soda lime. They are asking for the soda lime. So the lime is the presence of calcium oxide. You can form the soda lime by using sodium hydroxide. Yes, the formation of soda lime, OH and one O, this will remove as water, then you can form the soda lime, which is not commercially available. Then the reaction is heated and the product formed. So when the soda lime, it is heated with the sodium hydroxide and the lime, that is calcium oxide, the formation of the product is methane and the remaining sodium carbonate is here as the byproduct. So this CH3 group is utilized with the one hydrogen and remaining Na2, that is here is one sodium, here is one sodium, that is Na2, COO, that is two oxygen, one carbon, two oxygen, another oxygen is here, that is CO3. By this you can give the product. So look at the question now, name the product they are asking. You can just write the name, it has methane. So they are asking for only 1 mark. If you are write the product only methane, you will get the full marks. No need to write the reaction. Just for your confirmation, you can complete the following reaction. Yes. Next question is write the IUPAC name of the product formed when aniline reacts with bromine water at room temperature and the equation for the same reaction. So IUPAC name of the product formed. So what is the name of the product formed when aniline reacts with bromine? So first we can take the aniline. So aniline, it is reacts with bromine water. So take the bromine. So that is bromine in the presence of water. Yes, here the formation of the product, that is NH2. Now we are having the molecules, that is 3 bromine molecules. So it is taking the positions with the alternate form and the remaining, so 3 Br2 means you are having 6 bromines. So 3 bromines are participated in the formation of product. Another 3 bromines are removing the hydrogen atoms present in the benzene ring. So this is the product which is going to formed at the room temperature. Now they are asking for the IUPAC name. So you have to give the numbering. So you have to give the numbering for this. Yes, here is the ammonia group. 1, 2, 3, 4, 5, 6. So here 2, 4, 6 tribromoaniline. It is the product forward here. Next, write the increasing order of basicity of the following amines in aqueous solution. So here we are having the different forms of ammonia and the amine. So ammonia and the amine, they are asking the increasing order. It's very clear. So increasing order of the basicity. As you all know that acidity increases with the number of hydronium ions, basicity increases with the number of OH ions. But in this case, you have to think about the electron donating group. Electron donating group, or you can consider as the plus I effect. So this is the plus I effect. On that base, you have to write the increasing order. So in that, ammonia will takes the first place in the increasing order. Then the ethyl group, which is having the 3 forms of ethyl group, and next it is the next position, that is C2H5NH2, and at last C2H5 twice NH. So by the base of the electron donor, so electron donating groups, ammonia which is having the lone pair of electrons which is going to donate the electrons, and as the same is the plus I effect, that is inductive effect, they are ready to donate the electrons. On that base, here the ethyl group which is having the 3 times of the number, it will takes the second basicity. Increasing order means the second place the ethyl group which is thrice. Then here there is a difference in the hydrogen ions NH and NH2. So even the ethyl group is less in number, it will take the next position, and at last the twice ethyl which is having the twice takes the next position. Yes, how do you prepare benzene diazonium chloride? By the diazotization. Give the equation for this. So benzene diazonium chloride by diazotization. My dear all, what is diazotization? So here the conversion of the primary aromatic ammonia into the diazonium salt of the amine. So primary aromatic ammonia into the diazonium salt of the ions. So you have to prepare the benzene diazonium chloride. So the target is preparation of the benzene diazonium chloride. We can take the aniline. So when aniline is treated with the nitrous oxide, that is reacting with the HCl, giving the final product, that is C6H5 and the 2 molecules of water is released. So here this C6H5 is here, then one nitrogen and another nitrogen, that is benzene diazonium chloride. So we can call it as BDC, that is benzene diazonium chloride. Here the formation of the benzene diazonium chloride by the addition of HCl in the presence of the nitrous oxide, that is NO2H. So this benzene diazonium chloride is formed by the removal of water molecules. So my dear all, that's completes about your part D questions, and thank you for watching the video. Thank you very much.